Hello and welcome. In this video, I'm going to show you how to write a simple mathematical expression parser in C#. We're going to target .NET Framework 3.5 for compatibility reasons, and our parser is going to support complex things like functions with multiple parameters, variables and constants, operators of all different kinds and with multiple parameters as well. So hopefully you will enjoy this video and get something out of it. It's going to be divided in multiple parts. The first part, this one, is going to show you how to tokenize the input. The second part is going to show you how to refine that input in order to get meaningful tokens and meaningful info out of it. Then the third part will show you how to evaluate and return values from it using reverse Polish notation, which is a very powerful and common notation used in calculators, used in virtual machines like the CLR. So yeah, hopefully this will be useful. And let's get started. So first we need to create a console application that targets .NET Framework. We're going to call it Math Parser. We're going to make sure it targets .NET Framework 3.5, and we're going to place the solution and the project in the same directory. So let's create the project. And here we're going to have a simple entry code to the console application. We're going to remove the useless namespaces. We're going to set our program class to be internal static. Set our main function to be internal static as well. So first of all, what we're going to need to understand is how our parser is going to work. So here I have this simple text file, and I have this simple mathematical expression. Okay, so what's going to happen is our tokenizer, or our parser, is going to take a look at the input string, divide it into characters, and ignore the spaces, okay? Because in mathematics they are quite irrelevant. You can have this and it's still the same as this, okay? So what it's going to do is divide the input string to characters and then convert these characters to tokens. So our program is going to have a set of tokens. The main one is going to be the interface, which defines what a token is, okay? It's just going to be an empty interface that just helps us with like passing in different types of tokens. I didn't opt in for an abstract class because I wanted to give everyone the freedom to choose, like, is this class closed down, or should it be a struct or whatever. So it makes the tokens themselves quite extensible, okay? So what's this string going to be represented by is that we're going to have a digit token and letter tokens. We're going to have number tokens, and we're going to have word tokens. So as you probably can tell, the number token is going to be made up of digit tokens, okay? So it's going to be an array of digit tokens, and the word tokens is going to be as well an array of the letter token, okay? And we're going to have multiple different tokens for all of the other special symbols, like the left bracket, left parentheses, the plus symbol, the minus symbol, minus symbol, and all the different symbols. So first let's get started and create a new folder inside of our project and name it tokens. We're going to create a new interface and call it iToken. It's going to be a public empty interface that has nothing inside of it. So now I have created all the required token files. So we have a comma token for when we're separating function arguments. We have a digit token for when we find a character that represents a digit. We have a divide token that represents the divide symbol, exponent token, function left parentheses token, which is the parentheses, the left one that comes after the function name. The left parentheses token, which is just a normal one, number parentheses token, which represents the left parentheses in an expression, the starting one. We have a letter token for when we find a letter. We have a minus, a period, a plus, a right parentheses tokens. We have a times, an honorary minus token, and a word token. One thing to notice about tokens that represent immutable symbols, for example, the comma. There is only a single type of comma, okay? So that's why I make the class private, expose an static instance of it, which we can reuse, and that's pretty much it. So we don't have to say new comma, new comma, new comma each time we want to create one. As you can see, all the symbol tokens, like the divide, the exponent, the minus tokens, all have overridden toString method to represent this token in a string way. So for example, the minus token, when converted to a string, should return a minus symbol. The exponent token should return the exponentiation symbol or string or character. The divide token returns a slash, comma returns a comma, and that's pretty much it. For the digit and the letter tokens, as you can see, we override the toString method to return the letter converted to a string, okay? For the digit token, pretty much exactly the same thing. We override the toString method to return the digit converted to a string. And now for the number and the word token, we override the toString method to return a string that concatenates all the tokens that we have. So regardless of the token type, it will be converted to its string representation and put into the string. Okay, same for the number token, exactly the same, nothing really different. And that's pretty much it for all the tokens that we're going to need. Okay, now let's create a class and name it Parser, which is going to be obviously our parser. It's going to be a public static parser class. We're going to remove unused namespaces, and we're going to have a public static queue, a function that returns a queue of I token called tokenize, and it takes in a string, which is going to be our expression. So first we're going to have a variable or a var called output. It's going to be a new queue of I tokens. We're going to return this output. And here we're going to have another variable, we call it chars. It's going to be the expression to char array, okay, dot select, or actually we can remove the to char array thing. We can say select immediately. We say not char that is white space, but to array. So as you can see here, our expression is a string, and since a string consists of a character array, okay, we're going to use the link function called select and select all characters that are not white space, then convert the enumerable to an array. Okay, now we're going to use a for loop to iterate over the chars array. Okay, and we're going to say var current equals chars I, so the current character, and we're going to do something pretty simple. If we do a check if char.isDigit, the current, if the current character is a digit, simply we just second. This has to be aware, sorry. If our current character is a digit, then it's obviously going to be added as a digit token. So we say new digit token, taken in the current digit. Else, if the character is a letter, okay, say current, we obviously need to add a new letter token, taken in the current character as a token. Otherwise, we're going to use a switch statement. Okay. Here we're going to switch on the current. We're not going to need a default state because we don't really have one or need one. We're going to need to say, first our first case is going to be the plus symbol, plus char. So if the current char is a plus, we say that the output should enqueue the plus token dot instance. In case it's a minus, the output should enqueue the minus token. In case it's the star or the asterisk symbol or character, we're going to output .enq times token instance. In case it's the slash or the divide symbol, we're going to say output.enq divide token.instance. In case it's the up arrow or the hat or the exponentiation character, we're going to say output.enq exponent token.instance. In case we have a left parentheses, we're going to break here and say output.enq left parentheses token.instance. And in case we have a right one, a right parentheses, we say output.enq right parentheses token.instance. Okay. There are going to be a couple of special cases here, mainly the minus symbol, okay, and the left parentheses one. So, and also the plus symbol here. So we're going to say to see if we have an unarray, like an array plus, it's going to be ignored, okay? So how do we do this? We simply check and say if I equals to 0, so if it's the first thing in our expression, or the previous character is an operator or a special symbol that makes it an unarray, going to be ignored. So we're going to have a function called isOperator here, and we pass the chars I minus 1. We simply ignore it. So you see this continue applies to the for loop. Okay. Now let's create our isOperator function. So it's going to be a private static bool isOperator and take in a char c, and we simply do a switch statement on c. The default case we return false. Sorry, just need to return the return. Okay. So plus minus times divide exponent. Oh, and also we need the modulus operator. We need this. Okay, and let's actually real quick create a token for that. We close this. Now we go here, and this is pretty much it for our isOperator function. Now if we go down here, the error is gone. Now for the minus, we're going to say if I equals to 0, or the previous character is an operator, so chars I minus 1. We say output.enq the unarray minus token dot instance. Otherwise, enq a normal minus symbol. And back in our code here, let's go down all the way here and look at our parentheses, okay? I is more than 0, okay? So if it's the first thing, it's obviously not going to be preceded by a letter, okay? And char that is letter, the previous char. Then outputs.enq function left parentheses token dot instance. Otherwise, enq a normal parentheses token. Okay, pretty straightforward and simple. Now, if we are to go ahead in our program now and write the following code, so we go ahead and say for each token in parser tokenize console.read line. I'm going to say console.write line. I'm going to take in the token.get type name, okay, and preceded by its symbol. So for example, let's go here, yeah, let's say token.string here. Oh yeah, we forgot to add also .read line here. We need to discard this. Let's run again. And we're going to say -2 plus 2. As you can see, it picked up on the negative, the unarray minus. It says a digit token of 2, a plus token, and another digit token. Okay. If we repeat this again, but say -2 plus 2 plus sine 45 minus minus 11, as you can see. We'll see that it says there is an honorary minus at first. Then if we go all the way down, we're going to find 3 sequential letters, S, I, and N, sine, and it detected that this parentheses here is preceded by a letter, so it's converted into a function left one, and then 2 digits, and so on. As you can see, the digit token here as well, the 2 digits, the 11, so the 2 ones, are preceded by an honorary minus, and it picked up that there is one here that's not honorary, okay, because it's not preceded by an operator or something like this, okay? So that's pretty much it for the parsing phase. In the next part of this video, we're going to look on how can we refine this tokens into numbers, expressions, parameter arrays, and lots of more interesting and cool stuff. If you like the video, please consider subscribing and liking it. Consider sharing it and checking out my asset store assets, link in the description. Thank you very much for watching, and I will see you in the next part.